Okay, so good morning, everyone. Today we've got two lessons to go through. We've got measures of central tendency and measures of spread. You've also got a quiz to do this morning. And yeah, we're almost done our second week, which is super great. So I'm going to pull this up. Okay, so we've got quiz number 3 that's here. For measures of central tendency, this video will review shapes of distribution and introduce measures of central tendency. So answer the following questions while watching. I will not give you the answers for that. You should be able to do it. So watch the video, answer the questions. And so in this section, you will learn how to describe a set of numeric data using a single value. The value you calculate will describe the center of the set of data. The 3 measures of central tendency are mean, median, and mode. I'm going to take a bit of this empty space out. When we're looking at the mean, so a measure of central tendency found by dividing the sum of all data and then divide by the number of pieces of data. So you should have done mean, median, and mode in other math classes before. In statistics, it is important to distinguish between the mean of a population and the mean of a sample of that population. The sample mean will approximate the actual mean of the population, but the two means could have different values. So different symbols are used to distinguish the two kinds of means. So population mean is with mu here. And then your X bar is your sample mean. Okay, and it is sigma, so the sum of all your data, and then sigma, the same thing, over the number of values in your population. Okay, so a group of elementary school children were asked how many pets they have. Here are the responses, arranged from lowest to highest. What is the mean number of pets in this group? So what you do is, I'm going to take out my pen. Okay, oh, there we go. So you do X bar is equal to sigma of X over N. Okay, so that means you're going to add all these guys up. So you're going to do 1 plus 3 plus 4 plus 4 plus 5. My writing is fantastic this morning. Plus 7 plus 8 plus 9. And then you divide it by how many numbers we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So divide by 9. So if you throw that into the calculator, it gives you 45 over 9, which is 5. Excuse me. Okay. And so I'm going to clear that. So what does this number tell us? One way to think of it is that if every child in the group had the same number of pets, each would have 5 pets. This is the fair share value. And so we're looking at the weighted mean now. And so sometimes a certain data within a set are more significant than others. No, that should be in caps. For example, the mark on an exam is often considered to be more important than the mark on a term test for determining an overall grade for a course. A weighted mean gives a measure of central tendency that reflects the relative importance of the data. So weighted mean formula, if we look at, oh, sorry. Okay, so to find the weighted mean, we do X bar is equal to sigma XW over sigma of W. Okay, and so where X represents each data value and W represents its weight or frequency. So the personnel, oh, I gotta clear that. The personnel manager for a marketing company considers 5 criteria when interviewing a job applicant. The manager gives each applicant a score between 1 and 5 in each category, with 5 as the highest score. Each category has a weighing between 1 and 3. The following table lists a recent application or applicant scores and the company's weighing factors. Determine the weighed mean score for this job. Okay. So we are going to move this over there. So I'm just gonna type it out. It might like look a little messy. But X bar is equal to 4 times 2 plus 2 times 2. So you multiply these two and add them together. Plus 5 times 3 plus 5. Four times 1. And then the whole thing is divided by these numbers here. So you're weighing 5. So 2 plus 3 plus no 2 plus 2 plus 3 plus 3 plus 1. Okay, and if you throw that into the calculator, it gives you 46 over 11, which is 4.2. Okay. So we're going to look at example 3. So the table below shows a student performing or performance in the MDM4U class. What would their final mark be based on the weight? Okay, so just keep in mind that when there's percentages, you should be doing decimal versions of it. Okay, so X bar is equal to 92 times 0.15, which is the decimal of this, plus 86 times 0.40, plus 85 times, and so on. Okay, and then it will be divided by 0.15 plus 0.40 plus 0.15. Okay. And so that gives us 87.35 over 1, which gives us a mean or an average of 87.35%. For part 3, we've got mean of grouped data. Suppose your data have already been organized into a frequency table with intervals. You no longer have actual data values. You must then use midpoint of each class to estimate a mean weighted by frequency. So finding the average of grouped data is the same as finding a weighted average, except that you have to use the interval midpoint as the data value. Okay, and so the formula for this guy is X bar over sigma of MF over sigma of F. A sample of car owners was asked how old they were when they got their first car. The results were then reported in a frequency distribution, so calculate the mean. So I'm gonna have to clear this. Okay. So here are the ages and how many people got a car between those ages. So, we're gonna look at the solution. So we've got the frequency, we've got the ages. So we want to find the midpoint. So the midpoint for this is 18. This is 23. Okay, so the midpoint being the age in between here, so the mean, for example. Okay, and then you're gonna do this times that, which gives us 180, 414, okay, and then our sigma part here is 1270. And we're going to do the same thing for sigma here. So you add them all together and it gives us 50. And so that helps us with our mean. So X bar is going to be equal to this value here over this value here. And that is equal to 25.4. Okay, so we've got the median. So the median value is the middle data point. In a ordered set. Dividing the set into two sets of equal size. So to find the median of distribution, you have to arrange it in order of size from smallest to largest. If the number of observations n is odd, the median is the middlemost observation in the list. If there are two, then you find the mean of it. Okay, so if we look at example 5, monthly rents downtown and in the suburbs are collected from the classified section of a newspaper. Calculate the mean rent in each district. So downtown, we've got these guys. This should be the other way. Okay, and then the suburbs. Oh no, I had it the right way. My bad. Okay. Ignore that little part. So your first step is to start ordering the sets. So downtown, we've got 750 is the smallest, and then 800, and then 850. I like to cross them out as I go so I don't miss any. Okay. After that, we've got 1,000, 1,100. And then this guy, and then the following one. Okay, and then we order the following one. And so our smallest data is 220. And then 500. And then 550 and 585. And then 625, 750, 800, 900. Okay. So to find the mode, you want that middle number. So I cross them out along once they're ordered. So one on each side until you get to the middle. Okay, so this is our mode right here. He's left all alone. He's not crossed out. So we do the same thing with the suburbs. Cross one on each side. And we have two left, which means that you need to find the mean or the average of those two. So you'll do 585. Plus 625. And then divide by 2. Which gives us $605. It's supposed to be dollars. Okay. And so I'm gonna have to clear that. So downtown there are 7 elements in the set. So the median is the fourth element. Therefore, the median is $1,000 a month. For the suburbs one, there are 8 elements in the set, so the median is halfway between 585 and 625. Therefore, the median we said was $605. Okay. We look at the mode now. So the mean is the average. We've got the median, which is the middle piece. And then we've got the mode, which is simply the most frequent value or range of values. It is easy to determine the mode from a histogram as it is the highest column. Okay. So what is the mode of the salaries? So here we've got the highest, which is 750,000. Note that if no measurement is repeated, the data set has no mode. If it has two measurements that occur most often, it is called bimodal and it has two modes. Okay. So if you have categorical data, the mode is the only appropriate measure of central tendency. Okay, so we've got the median that's in the middle here. The mode is the largest, and the mean would be your average. Okay, so the median is less in this case. The mean is greater than the median. Okay, so we look at the mean here, and the median. Okay, and this one is equal. Okay. And I believe that is all. So you are off to do your practice questions. And then there's another video coming up.